Cliff Mass is going to come and give us a climate update. He's a professor in the UW Atmospheric Studies Department and a well-known expert on the weather of the Pacific Northwest. Please join me in welcoming Cliff Mass.
Well, that really is a hard act to follow. Well, I should note there's more humor about meteorologists than any other discipline, so I could have been ready for that. Well, today I'm going to talk a little bit about global warming. I'll talk about some of the basics, we heard a few of them, and a little bit about the implications for the Pacific Northwest. Now, there is a great deal of contradictory information about global warming out there. A variety of local environmental groups have proposed that global warming has caused our weather to become more extreme. Some have talked about substantial warming already occurring. In contrast, others hold the lack of warming of the planet during the last 10 years indicates that global warming is no real threat. And that the scientific idea of a scientific consensus on global warming is a myth. Some people ask, I'm asked this all the time, how can scientists predict the climate when they can't get next week's weather right? I get asked that question all the time. But at the same time, thousands of scientists from around the world have written a series of reports indicating that there is an imminent threat of global warming due to mankind's influence. And then you all know about this, right? The IPCC reports. So what is the truth? What is biased and wrong? What do we know for sure? What are the uncertainties and what's going to happen here? That's kind of a few things I'm going to talk about very briefly. Well, you all know the problem. The essential problem is that greenhouse gases are increasing. And this is just a plot of CO2 historical in the future, and what it shows is two projections into the future, but it's going up, and it's going up rapidly. Now, greenhouse gases, they're called greenhouse gases because they are very active in the infrared. They act essentially as blankets, atmospheric blankets that help warm the Earth. The analogy with the regular blanket is actually not so bad at all. I won't go into the details of it, but it's not bad. And carbon dioxide is not the only greenhouse gas. In fact, the number one greenhouse gas is water vapor. That is the most important. The dominant greenhouse gas is water vapor. But there's also methane, nitrous oxide, and others. Now, starting with Arrhenius a while ago, but certainly now, we have a really good understanding of the greenhouse effect. Ironically, the greenhouse effect doesn't work in greenhouses, but that's for the next comedy routine. Oh, this thing is just going ahead. I hit the wrong button. Yeah, how would the laser thing?
Green button. To forward it?
No, just to hit the laser.
The green button.
Okay.
There.
Okay. Anyway, we understand the greenhouse effect, and I'm not going to go into details. Basically, the atmosphere is relatively transparent, invisible radiation, where most of the radiation from the sun is found. That gets through the atmosphere, warms the surface. Surface warms, radiates heat in the infrared, and the greenhouse gases in the atmosphere absorb that and re-emit it down to the surface and up into space. And basically, this re-emission down is a key part of the greenhouse effect that helps to warm up the planet. So the planet is much warmer than it would be because we have these greenhouse gases. Greenhouse gases are good. This planet would be too cold to live on if we didn't have them. Now, we have the ability, substantial ability, to predict the future effects of greenhouse gases using what are called climate models, generally general circulation models. Now, these are sophisticated computer simulations that are based upon the physics of the atmosphere. These models are nearly identical to the weather prediction models which are run and tested each day. And, these models are very good, but they are not perfect. I am a numerical modeler. That is my business. I do numerical weather prediction. I know the weaknesses of these models. And they exist. But as you know, weather forecasts are getting better and better and better, getting away from any of the humor here right now. And a lot of these ideas go into the climate models, which are basically the same models, except that the greenhouse gases can change in time. Now, there are uncertainties here. One of the major uncertainties is how much the greenhouse gases will increase in the future. And this is a plot from the IPCC reports showing you the CO2 emissions, one of the greenhouse gases, in time, and they have various scenarios. And for instance, scenario A2 is where we pretty much keep on going what we're doing now, okay? And there are scenarios where mankind actually takes steps to try to reduce our greenhouse gas emission. And then we can see like B2 over here, A1B, etc. So this is an area of uncertainty. 10 minutes. Talking about uncertainties. There's uncertainties in the magnitudes, a lot of the major forcing functions. This is from the IPCC report. This shows you the radiation is the key way that energy is communicated in the system. And if you look at their report, there's uncertainties about contributions of how the land use is going to change, about greenhouse gases. There's about how much dust is in the atmosphere, and aerosols. There are all kinds of uncertainties. And so if you look at the total effect of mankind, the radiative forcing, I mean, our best guess is warming, but this shows you the error bars. They're substantial, but they're all in the direction of warming. So I just want you to keep, we're very confident there'll be warming, but the magnitude has some uncertainty. Very important to keep in mind. And so if you look at the IPCC report or look at research studies, you'll see figures like this. 1900, 2000, 2100. This is the change in the global temperature for various scenarios. And you'll see for each one of these scenarios, like A2 over here, A2 is an aggressive one, things are warming, there are uncertainties. In fact, what they ran here was a series of general circulation models. Let's look at the A2 scenario. And you can see there's a wide range of temperature variation among these models, run by different countries and different groups. So there is substantial uncertainty. They're all in the direction of warming, but we're talking about range from 2 to 5 degrees centigrade here. So there's uncertainty. They're all going in the direction of warming. So, now we can take a look at one of these simulations. This is an A2 simulation. And this is based upon averaging in a number of these global climate simulations. And one thing you see right away is global warming is not globally uniform. Really important point. Virtually all the models show that the Arctic warms up more than any place else, that the continents warm up more than the oceans, and in fact the western oceans warm up more than the eastern oceans. And keep that in mind, because we're going to get back to that. Where do we live? Okay? We live downstream of an eastern ocean.
Western.
No, we're in the East Pacific. We're downstream of the Eastern Pacific. That's what I meant to say. We're downstream of an eastern ocean. Anyway, now another issue is that the global models that most of this work is based upon, the IPCC report, these are generally global models, which don't have that much resolution. If you look at the air temperature from these global models, this is what it looks like over the Northwest. These models don't have the Cascades in them, the Olympics or anything. All the local details are not in there. So a big issue is, we have an idea what may be happening globally, but what's going to happen locally? Because these global models don't have the resolution to get the local detail. Okay? And there may, in fact, be surprises. Maybe when you put the mountains in and the land-water contrast, that could change the story locally. Okay? Really important. So the bottom line of the first part I'm talking about, it is clear the Earth as a whole will warm, and the rate of warming will increase. In fact, all the simulations show it's almost exponential. The main warming is ahead, not in the past, not now. It's in the future. There is substantial uncertainty in the magnitude of the global warming, roughly 1 to 4 degrees centigrade. And the interesting thing is that with all our research and all our work, these uncertainties have not decreased. Because as we've learned more and more and put more and more details in, the uncertainty has pretty much remained the same. And even more uncertainty exists about the local implications of climate change. So what about here in the Northwest? What are the implications? First, interestingly enough, it appears there has been very little warming here in the Northwest over the last 30 years, irrespective of what certain mayors have said. Now this makes sense, because we are downstream of the Pacific Ocean, and the Eastern Pacific is one of the last places on the planet that's going to warm significantly.